Hello guys, welcome back to my channel. Today we're going to be looking at the May-June 2022 CXC Mathematics past paper. And without further ado, we get right into it. Now, question 1. Before starting the question, we must read the instructions properly, which says, answer all questions. All working must be clearly shown. Alright, so we get into question 1. Now, question 1 says, using a calculator or otherwise, find the exact value of this. Now, I'm going to start by finding it without a calculator because there's something that we should know even though we're not using a calculator, right? So we have addition and we have division. We're going to resort to what we call BIDMAS. Now, BIDMAS means bracket, indices, division, addition, and then subtraction. All right, very important. So let's get right into it. Now, it means since we have addition and we have division, because in BIDMAS division comes first, we have to do our division first, right? So I'm going to have 1 over 6 divided by 2/9. Now, how does this work, right? Now, when doing division, we know that division is really inverted multiplication. What does that mean? It means I'm going to have 1/6, which is my first fraction, and then I'm going to multiply by the reciprocal of my second fraction. So that's by 9/2, right? At this part, we can use reduction. And bear in mind that we normally use a numerator and a denominator when doing our reduction, right? So for example, I know that 9 is a numerator, 6 is a denominator. What number can go into both of them? I know 3 can go into 6 2 times and 3 can go into 9 3 times, right? Is there any other numerator and denominator that can be reduced? No. What does that mean? It means that we're going to multiply across. So I'm going to say 1 times 3 is 3 and 2 times 2 is 4. Alright? So that's my first part. Now I'm going to put taken right here because I took out part of the fraction and I worked on it. Now I'm going to recombine them, right? So I'm recombining. So what it means is that I'm going to go back for my 7/8, which I need to add now to my 3/4 because this is the part that I did first. Now, what do? We simply find the LCM, which is the lowest number that 8 and 4 can go into. But since 4 can go into 8, automatically, my LCM is 8, right? Now we say 8 into 8, of course, goes 1 time. And of course, we use that one to multiply my numerator, which is 7. The addition sign comes back, of course, right? And we say 4 into 8 goes 2 times. And we use that 2 to multiply the numerator, which is 3. Alright, almost there. Now we can say 1 multiplied by 7 is 7. And 2 multiplied by 3 is 6. Once again, you have to multiply before you add. We'll put it back over 8. This becomes 7 plus 6 is 13 eighths, right? Now, of course, you know that this is improper because my numerator is larger than my denominator. So we're going to turn it into a mixed fraction. Now, 8 goes into 13 1 time. And we say, what is my remainder? How much do I add to 8 to make it into 13? We know that's going to be 5, right? So it's going to be 1 and 5/8. And that is how we get our answer. Now, what if we wanted to use a calculator? This is where I'm going to bring in the calculator here. Because this entire process can be done using your calculator. And it's good if you have a calculator like this, where a fraction looks like a fraction. So let's see what happens. So I'm going to put in my fraction button, and I'm going to put in 7. Press my down arrow, 7/8. Alright. Add it to, and of course the calculator is programmed to do division first, so you don't have to worry about that. So I'm going to have 1/6. And then I'm going to put divided by, of course you can press the numerator, then the fraction bar, then the denominator. I think that probably makes it easier. So you're going to have 2, fraction bar, and then press 9. Pretty good, right? And this is equal to 13/8, which is what we got. Now if I want this now to probably become a mixed fraction, what I could do here is that I could press shift and press this button. We have S to D, right? That is it. Now, normally, this takes it from the standard form to a decimal, but once you go shift in the background, you realize that you have the mixed fraction, which is 1 and 5/8. And of course, this I would simply have written down here if I were to use the calculator, right? So I could write a statement that says, using the calculator, I put all this in and I write down the answer. Or if you want to do it step by step to show that you understand it, you could do the division part first, write down the answer, and put in the addition part. Alright? That part is up to you. Now let's take this down a bit. Alright, now here we have 8 divided by 0.4 cubed. Of course, always keeping BIDMAS in mind. The fraction bar means I'm going to be dividing. That is what the fraction bar represents, right? So we can put, in fact, let me start this one by showing you how we can put the entire thing inside of the calculator, right? So I could go, let's get all of this out. I could go 8, or I could do it in steps. Tell you what, let's show some process. I know I have to do indices first. So I can go 0.4, and of course, I can use the third power, or I can use this button right here, which means I can put any number up there as a power, right? Alright, so that's 0.064. So this actually becomes 8 over 0.064. Now going back for my calculator again, I can say 8 divided by 0.064, which turns out to be 125. So this is equal to 125. I could also put the entire thing in the calculator, but as I say, we can do it step by step. Alright, let's break this down. Now here's an interesting question, and if you really know how to use a calculator, you might want to try to see if you can put all of this inside of your calculator one time. Now let's give it a go. Let's give it a try. Alright, here's my calculator here. And I want to put this entire thing inside of my calculator. Alright. Let's go for my square root. This is my square root symbol here. So I'm going to have square root. And under my square root, I'm going to have 26.8. Now, of course, persons normally tend to make the error of not coming outside of the square root. So I need to put the arrow right here. So it means that I'm outside of the square root now, right? And I'm going to subtract. That's 2.5 raised to. So I press my raised to symbol and I have a fraction there. So what it means is that I'm going to have to put in my fraction next. Now, so I press my fraction bar and that power is 3 over 2. And then we simply press the equal. Now it says correct to 2 decimal places. So you're going to have to count off 2 decimal places. So after the point you have 2, 2. What comes after the second 2? 4. Which means the number remains the same. So my answer to 2 decimal places is simply 1.22. Of course, you have the option of doing this in phases where I can simply find the square root of the first part, I can find the second part, and then I can subtract. Alright? However, all we have to always remember is that we use BIDMAS. Alright? To keep it in that order. Okay, let's go to our next page. Alright, this says question, and this is question B, of course. It says, children go to a rodeo camp during the Easter holiday. Miss Riha buys bananas and oranges for the children at the camp. Bananas cost $3.85 per kilogram. Miss Riha buys 25 kilograms of bananas and receives a discount of 12%. How much money does she spend on bananas? Now, there are several ways to do this. Since we are getting 12%, I can find 12% of the unit price and then we simply multiply by 25, or I can find the total cost and then multiply it by find 12% of it. Either way you get the same answer, right? It's up to you. So let's say this is a cost, and of course it's important. This is a cost per kilogram, which means that 1 kilogram costs $3.85, but we are buying 25 kilograms. So what it means is to get the total amount, ignoring the discount, is to simply multiply 25 multiplied, and I'm using the dot here as my multiplication sign, by $3.85. So if the discount was not there, and of course this is a calculator work. All right, let's pull up the calculator. So I'm gonna have, let's clear this, 25 multiplied by $3.85. All right, and of course I'm gonna turn it into a decimal. That's $96.25. So I'm gonna have $96.25. This is the total. Now my discount is 12%. So what I want, so here's my option. We have two things we can do. The original price of any item always represents 100%. So this is 100%, right? They take off 12%. So I'm going to go 100% minus 12, and that is going to give me 88%. Which means that the cost that she's going to pay is 88% of the original price without the discount. So I can go 88, percentage means per 100, so it's 88 over 100, multiplied by the total price that she paid here, which is $96.25. Alright, so let's pull up my calculator because I don't want to have to do much work. Let the calculator do all the work for you. So here goes my fraction bar again. I'm going to have 88 over 100 come to the side, which means I'm going to multiply by $96.25, and that is going to give me $84.70. So that's $84.70. Now somebody might be asking, why did I not find the discount first? You can do that. However, normally you try to do the work that is less. You want to do less work. Now let me show you that you'd actually get the same answer. So I could have gone ahead and found 12% of the total amount, which is 12 over 100, multiplied by $96.25. So this is me finding the discount. Let me call it D. Discount equal. What I've found over here is what we call the discounted price. Let me call it DP. Discounted price means the price that you pay after the discount is taken out. So it works both ways. So I can either find 88% of the total sum, or I find a discount, and let's show, without saying much, let's show you that you get the same answer, right? So let's clear this. I'm going to have 12 over 100, and I'm going to multiply this by $96.25, right? Notice I'm allowing my calculator to do most of the work for me. That's going to give me $11.55. All right. So good so far. Now, to get my discounted price, which is DP, which is what I want, I'm going to take my total, which is $96.25, and I'm going to subtract the discount that I have to pay, which is $11.55. Good. Now let me pull up the calculator just to show you that the answer will be the same. So we're going to clear all of this, and we're going to say $96.25, and I'm going to subtract $11.55. And there we go. We get $84.70. You have two options. You can choose the easier way. All right. All right, let's take this down. All right, Miss Riha spends $165.31 inclusive of sales tax of 15% on oranges. Calculate the original price of the oranges. Okay, so the original price was lower. When they added the tax, this is what it became. The key word here is inclusive. That's the operative word, which means that this price contains the tax. Now, how do I work this out? Always remember that my original cost represents 100%. That is the original cost. Now, what did they do? They added your original cost. Let me call it O for original. Let's clear this up here. Original costs plus tax to get this value here, which is $165.31. So what it means is that this cost here actually represents 100% plus your 15% tax, which is 115%. That is what this here represents. But I don't want that. I'm interested in the original price, which is 100%. Now, what do I do? Since we have this amount, we can find the original price, which is 100. So whatever I want normally goes in my numerator, right? So I want to find the original price, which is 100. I have the current price that I have represents the original price added to tax, which makes it 115, right? So that is what I have here. So 115. And now I'm going to multiply it by the cost that is represented by the original cost plus the tax, which is $165. That is $165.31. So that's $165.31. Hope we make sense of this, right? The key to this, or the key to solving this, is always to remember your original cost is 100%. When they added the tax, this 100% now became 115 because tax was added. So in order for me to get my original price, I have to refer back to 100%, which represents my original price. I put it over what I have now in terms of percentage, which is 115, and I multiply by the cost I have now, which is $165.31, which includes both the original price and the tax price. Now, after doing that, there is pretty much nothing you have to do apart from use your calculator properly, right? So I'm going to have 100, fraction bar 115. All right, we go across and we multiply that by $165.31. All right, that gives me that. I press S to D, which means I'm going to put it in decimal. Okay, let's see what happens here. I have $143.74. All right, good. What am I going to do? Since we have a 7 afterwards, I'm just going to round that up one position, right? Because remember, whenever the number that comes after is 5 or more, we round the number we were stopping up by 1. And bear in mind that money has only 2 decimal places, right? So that's $143.75. Okay. Let's get that down here. So this is equal to $143.75. Do not forget the money sign, alright? Without the money sign, it's not money. Alright, let's take this down. Alright, the ratio of the number of bananas to the number of oranges. So, two quantities of banana to 3 quantities of oranges, right? So what does this mean? It means that for every 2 bananas, you have 3 oranges. That's all it means. That is what ratio deals with. I have 2 bananas, I'm going to have 3 oranges. If I double the amount of bananas, I double the amount of oranges, right? Alright, furthermore, there are 24 more oranges than bananas. Calculate the number of bananas Miss Riha bought. Okay. Let's take this down. Now, I can make this question as easy as possible. The ratio is 2 to 3. Alright? Now, if you subtract these, 3 minus 2 is equal to 1. Alright, so this oranges has 1 quantity over the amount of bananas, right? Which simply means I have 2 oranges, I'm going to have 3 bananas. That's the simplest ratio. Alright, good. Now, it says there are 24 more oranges. So this one portion is equal to 24. How did I come up with that? You have 1 portion of orange more than bananas. You have 24 more oranges than bananas. So what they're saying is that if you take the amount of oranges and you subtract the amount of bananas, you're going to get 24. So that 1 portion represents 24, just like how we subtracted the ratio. A similar concept is being applied here. Now, if I know that 1 portion is represented by as 24, and of course it says calculate the number of bananas, and I know that the quantities or the amount of portion of bananas is 2, all I simply have to say is that 2 times 24, which gives me 48, is equal to my number of bananas. Simply put, alright? And this is the simplest way to work it out. We don't need to complicate the question. That's a simple way to put it, alright? We know how much portion we have of oranges than bananas. It's just 1 more portion. And they stated to you that you had 24 more bananas, which means that that 1 portion more that you have is simply going to be 24. And if you know that 1 portion is 24, then guess what? How much is 2 portions? It's 2 times 24. If I was interested in finding the number of bananas, I would have simply gone 3 portion multiplied by 1 portion, which would be 3 times 24. And you'd have gotten the answer. Alright? Now let's take you over to the next page, which goes to question number 2. It says factorize completely the following quadratic expression. Alright, now in factorizing quadratic expression, it's all about knowing your timetable. Alright, I'm going to have to go AC. So remember, you have a x squared plus bx plus c. Alright, that represents my quadratic expression. So I'm going to say 5, and it's a positive 5 multiplied by a positive 4 is going to give me a positive 20. Now I want two numbers that I multiply to get 20, but when I add or subtract them, I'm going to get a negative 9. Now this is how it works. If this quantity is going to be positive and this quantity in the middle is going to be negative, what it means is that the two numbers either have to be positive or the two numbers have to be negative. Now, of course, the two numbers can be positive, because if you add two positive numbers, you're going to get a positive number in the middle. So it means that the two numbers have to be negative, because there's only two ways that you can get a positive, right? Multiplying a positive by a positive or a negative by a negative. Now, what two numbers multiply to give me 20? That when I add them, I get 9, ignoring the negative sign at first. So imagine that this was positive. Alright, let's go. We can go 2 times 10, which is 20. But 10 plus 2 is not going to give me 9. That's going to give me 12. Now, bear in mind that since both numbers would be negative, when I add both of them, it would just be like I owe 2, I owe 10 more, I'm going to owe 12. That's out of it. We can go 20 and 1, right? Which is negative 20, negative 1. Negative 20 plus negative 1 is going to be negative 21. So that's out. Alright, what about negative 4 and negative 5? Negative 4 plus negative 5 is negative 9. So that is what we're going to be using. Now, what do I use these numbers to do? Of course, the first two terms remain the same. So you're going to have your 5, you're going to have your 5x squared, and you're going to have your plus 4. That will always remain the same. These two numbers will now come in the middle to rewrite my negative 9, which means it doesn't change. So I'm going to have minus 4x minus 5x. This is still negative 9. Why is this so important? Because now I have 4 terms, so to factorize, we can simply pair them off. Good. Now you're going to only be focused on the first two terms. What is common between these two? We normally start with the numbers. Only one is common. Only one can go into both 5 and 4. So, not too interested, right? What about x? We have x squared, we have x, which means we have at least one x that's common. So we take that out. Now, if you have an x squared, you take an x out of that, you're going to have x left. The 5 was not touched, so it comes back as a 5x. This term only has 1x. So when you take it out, there's nothing going to be left there apart from my 4, right? Now, over here, what do I do? Now, we don't have any common x's. We have 5 and we have 4, but we have to factor out something out. So what we can do is factor out a 1. Now bear in mind, the idea is to have the things in the same, in both brackets being the same. Now this is positive. I don't want that. Now how do I change that? I simply factor out a negative 1, which means that if I factor out a negative 1, this term, which is 5x, becomes positive because that negative is gone, and this term, which is positive, becomes negative, right? So when I re-expand, I get back my original term. Now look at this. Both brackets have the same thing. So this is where I'm going to factor out the bracket and what is inside of the bracket. So the bracket is common now, and everything inside is also common. So you take it out. 5x minus 4. Now what would be left? If I were to take this out, let me use a color to write them out. You take this out. This is gone as well. All you have left inside of the bracket would be x minus 1. And this is my answer. Not too bad, right? Hence solve the following equation. Now, normally when a question says hence, it means that you're going to go back to what you had before to solve it. Because this is quadratic, to solve it, you'd have to factorize first, or you'd have to use a quadratic formula, or you could complete the square. Whichever works. Although technically completing the square is really the quadratic formula. So I'm going to go back for this, which is 5x minus 4 times x minus 1 is equal to 0. It makes it easier to work this way. Why? I know that if two things multiply to give me 0, then one of these two things must be 0. So 5x minus 4 is either going to be 0 or x minus 1 equal to 0. Now you have two simple linear equations, so we get right into solving them. This is what I say. This 4 is negative, is going to come over, right, as a positive. So 5x is equal to 4. 5 is multiplying, the opposite is to divide both sides by 5. So x is equal to 4/5, or in this case, very simple, we have a minus 1. We bring it over, so we have x equal 0 plus 1, which is equal to 1. So x is either equal to 4/5 or positive 1. Not bad. Alright, B. It says make V the subject of the formula. It's just an next way of saying solve for V. Now notice you have V all over the place. So the first thing that I need to do is to group these two things, right? Now, because this is a fraction, I'm going to make it easy by putting W over 1, because that doesn't affect the fraction any at all. Now, why did I do that? Because I can simply cross multiply right now to get rid of this fraction. So I'm going to have W in bracket. I'm going to have V minus 3. I have a bracket because I need to multiply one thing by more than one thing, right? Then I'm going to have 1 open bracket 5 plus V. Okay, good so far. Now let's expand this. Now W times V is WV, and W times a negative 3 is minus 3W. Don't forget that this is negative, right? This is equal to 1 multiplying it by anything will give you back 5 plus V. Now, since I'm solving for V, all my V's need to be on one side, which means that this positive V that I have over here needs to come over to where I have WV. This can go over, the 3W can go over. I'm not interested in that. So let's do that. Now follow me carefully. This is going to come over. It was positive, so it comes over as a negative. This is going to go over. It is negative, so it comes over to be a positive. Alright? So it becomes WV. Remember, that comes over as a minus V. The 5 is still over there, which is a positive 5. And that negative 3W comes over as a positive 3W. So good so far. Now we still have two V's, and that can't happen. Why did I bring them to the same side? The whole idea is that it is now common to both terms, so I can factor it out, because I need to have only one V. Now by finding out that, I'm going to have W leave for the first term. Okay? So I'm just going to have a W leave here. Now nothing is going to be left here. So to keep that position, so I can re-expand, I'm going to put a 1 there. And this is equal to 5 plus 3W. Now that I have V by itself, I need to have it alone on that side because it is what I'm trying to find. So I'm going to have to ask myself, what is this entire bracket doing to my V? It's multiplying it. So I'm asking, what is the reverse? Division. So in order to get rid of the entire W minus 1, I have to divide by that entire thing. And I can't just do it to one side, I have to do it to both sides. W minus 1. Now this is gone. Let me use my yellow line. This into this is 1, right? So that's gone. So now I have V is equal to 5 plus 3W over W minus 1. It doesn't matter that I have W at the top and the bottom because I'm not interested in finding that. What I'm interested in finding is V. Alright? So let's see. This takes me to my next page. Let me just pull this down here. Alright, so let me ensure that I had everything on the previous page. So this was 2B. I'm now going to move on to 2C. Now please remember to read all the questions very carefully. Alright, this is what 2C says. It says the height h of an object is directly proportional to the square root of its perimeter. Now, let's do that exactly what they say. This is how you make the thing easy. The height is directly proportional, and that's my symbol, to the square root. So you put the square root symbol of its perimeter P. So you put the P underneath the square root. So you're doing exactly what the question says. So the height is directly proportional to the square root of the perimeter P. Write an equation. This is not an equation. This is just telling me that it's proportional, right? Which means that the height is equal to some constant K. Do not forget about this. This is the critical part. When it's directly proportional, it doesn't mean it's equal to it. What it means is that as one increases, the other one increases, but there's a constant, right? There's a constant here that keeps that in line. So for example, let me just get that in theory to you. Let's say you have the number of oranges, like the previous case, is directly proportional to the number of, let's say, of bananas. So we have 2 to 3, right? So what it means is that if I'm gonna have a constant that if I use it to increase this, I would also have to use it on that as well. Right. So we're gonna say that h is equal to k times the square root of p. So the height is equal to the constant times the square root of the perimeter. This constant never changes. It's always going to remain the same. Right? So now we have the equation right here. This is my equation. Now let's take this down to question part 2 of the question. Part 2 says that given that the height is 5.4, when p is equal to 1.44, determine the value of the height when p is equal to 2.89. So the first thing I need to do is that I need to find a constant, right? Using this part of the information, ignoring everything else. So we have 5.4 is equal to k, which I don't know, times the square root of the perimeter, which is 1.44. All right. Now you can use a calculator here. Let's clear everything up. So the square root of 1.44 is equal to, let me delete this. The square root of 1.44 is equal to 1.2. So we're going to have 5.4 is equal to k times 1.2. Which we know we have, in order to find k, we're going to have to do the opposite, which is to divide both sides by 1.2, right? So k is equal to, once again, you don't have to do anything. Bring in your calculator, delete everything, and you're going to say 5.4 divided by 1.2. That's going to give me 4.5. So I know that k is equal to 4.5. Now we go back to the equation. We always go back to the equation. So my height is equal to 4.5 times the square root of p. This is called the constant of proportionality because it will never change. It will always be 4.5, right? The constant of proportionality. Okay, so let's see the other things that can change. Height can change, p can change. They will vary. Now it says find the value of the height when p is equal to 2.89. So we want the height. The 4.5 will come back times the square root of 2.89. So my height is equal to, we have the option of putting that entire thing inside of the calculator, which is important that you know how to use the calculator, right? So I'm going to have 4.5 multiplied by the square root of 2.89. That's 7.65. So my height is 7.65. Not bad at all. Let's bring this up and see if we have any more questions. And that ends question 1 and 2 on my 2022 CXC Mathematics past paper.